Hey guys, welcome back to my channel. So today we're going to discuss about applications of linear algebra in our daily life. So the agenda of today's presentation is geometry of surrounding space, analyze of functionality, research into more complicated systems, scientific computation, cryptography, the theory of games for the purpose of encoding and manipulating signals, linear programming, data scientists, algorithms for prediction. So coming to my introduction, I'm a first year graduating student at SVC Bangalore. My name is Sainandan, I belong to Audi session, and the topic for today's presentation is application of linear algebra, and my branch is computer science and engineering. So coming to the point, the geometry of the surrounding space. The use of geometry as the foundation of modeling ambient space. The use of geometry is widespread in scientific discipline considered with this space. This is the case with machines and robotics. In order to describe the dynamics of rigid bodies, geodesy, in order to describe the shape of the earth, perspective, computer vision, and computer graphics, in order to describe the relation between a scene and its plane, representation, and many other scientific fields. Then the next thing we are going to discuss is analyze of functionality. The study of function spaces called as functional analysis. These are vector spaces that also have some additional structures like Hilbert space. Therefore, linear algebra is an essential component of functional analysis as well as the application of functional analysis, which particularly include quantum mechanics, wave functions. Research into more complicated systems. Partial differential equations are used to model the vast majority of physical phenomena. In order to solve them, one must typically decompose the space in which the solutions are searched into the numerous small cells that are in constant communication with one another. This interaction requires linear functions when dealing with linear systems. When dealing with nonlinear systems, it is common practice to model the interaction using linear functions. In both instances, the matrices involved are typically very large size. In case of weather forecasting, a typical example, the atmosphere of the entire planet is divided into cells with a dimension of say 100 kilometers in width of 100 meters in height. Scientific computation. Almost all that are done in a science, computations that are done in science involve linear algebra. As direct result of the as direct result of this, linear algebra algorithms have been fine-tuned to extreme high degree. The most well-known implementation are known as BLAs and LAP lab packs. Some of them are automatically configure the algorithms while the program is running in order to improve the system's overall efficiency by tailoring the algorithms to characteristics of computer, cache size, or a number of available cores. Some processor, most commonly graphic processing units (GPU), are built with matrix structure for the purpose of improving performance of linear algebraic operations. Cryptography. It is a study of both decoding and encoding, which are used to communicate secret information. Strong encryption methods are able to implement with the use of electronic commerce and communication. In order to decode and encode the message using these methods, model arithmetic is required. The more straightforward encoding strategies can be implemented with the help of matrix transformation ideas. The theory of games. Another one of the application of linear algebra, which is a mathematical study that counts the various possibilities. This one uses it to count number of choices during the course of game. The player decides how to proceed with the various options. According to the findings of psychologists, social interaction theory is applied when analyzing the player's options in relation to those of the other competitors in the game. For the purpose of encoding and manipulating signals, such as audio and video signals. linear algebra is utilized during the processing of signals. In addition to that, it is necessary for the analysis of signals of this kind. Linear programming is a method of optimization that can be utilized to ascertain the linear function that will yield most of the desirable result. Data scientists in the field of computer science employ a number of linear algebra algorithms in order to solve difficult problems. Algorithms for prediction. Prediction algorithms make use of linear models that are developed through the application of linear algebra fundamentals ideas. Conclusion. The study of planes and lines, mapping and vector spaces, all of these require a linear transformations, and essentially which linear algebra is all about. As a result, it is essential to have understanding of the various applications of linear algebra. Although linear algebra is considered to be a subfield of mathematics, the more accurate description of its purpose, the mathematics of data, the language of data represented by matrix and vectors, is called as linear algebra. Thank you for listening to my video, and if you like my video, please consider liking my video and consider subscribing to my channel.